Today we will continue with the next number programs, okay? Next set of number programs. So here, what I will say is, I think you guys remember how to find a factorial, right? I think you guys know how to find out a factorial for a number. Yeah. So if you're clear with that, so next I will move on to definition of strong number. So today we shall see how to find out if a number is strong number or not. What number we are discussing for the what is the first number? So what is the first program for the day? Your first program for the day is strong number. So it is just a what to say upgradation of a factorial program. Okay. So strong number. What is strong number? Basically, strong number is a special number whose sum of factorial of digits is equal to the original number. Okay. So, for example, they have given a number which is 145. So, if we break down this explanation, so what will happen? So, what is 1 factorial? 1 factorial is 1 plus 4 factorial is what is 4 factorial? 4 factorial 2 na. 4 factorial is uh, 4 factorial and what is your 5 factorial? It is 120. So if you add all these things, if you add all these, you will again get a 145. See, what did I do? I have a number which is 145. So here what I will do, I will split each number. I will split what? I will split each and every number. No. It's okay, fine. So I will split each of the number and for individual number in individual digits in the number, I will find out the factorial for every digit. And once when I get the factorial value, what I will do, what is that? I will add the values of the factorial. So once all the digits factorial is received by you, so I will check whether the sum value is equal to the original number. Okay. So how many of you understood the definition? How many of you understood the definition? I think so. It's a pretty simple definition, right? So I hope so. Everyone has understood the definition. Shall we see how to perform this operation? So taking a number, performing individual factorial, and doing sum for every factorial and checking whether the summation number is equal to the original number. So shall we see the explanation for this number? Is my voice audible for you people? Yeah. Why there are less people today? Is there any exams or anything for you guys? Can see half of the almost only 60% of the population. Why is it? Okay, so let's come with this. So first, let us write down what things we have to do. Okay, step by step procedure. So in the step by step procedure, first have a number. So first, what you have to do, you should have a number. Okay, then obtain the unit digit. What we have to do, we have to obtain the unit digit. Obtain the unit digit. Find the factorial value of the obtained unit digit. Sum the values of the factorial. Just a minute, guys. Okay. So sum the values of the obtained obtained factorial value. Value. Next is check if the sum value is same as that of check if sum value is same as that of the original value. Okay, these are your steps what you have to do to check if your number is strong number or not. Okay, so shall we convert these steps into programming instructions? Shall we convert these steps into programming instructions? I think so. Okay. Okay. So here, first, what I have to do, I have to have a number. So we have a number in our hand, which is 145. So next thing is we have to obtain the unit digit. Okay. Next is to find the factorial value of the obtained unit digit. So we know this step, right? We know this step. We know how to perform factorial for a given number. So can I create a separate method to find out factorial of the unit digit? Can we perform a method? Can we create a method? Can we create a method for this? Just a second, guys. Okay. So here, first of all, what I will do, let me create. I think so. I am in unmute position. Yeah, I am in unmute position. So here, what I will say, public static. So here I will say integer value. I will say factorial. So this method has to receive a number. So that is why I am having a parameter which is accepting a integer type in the name of num. So here I will say int fact is equals to 1 or int I is equals to 1, I less than or equals to num I plus plus. So here fact into equals I. So here I have to return the fact value. So we know this method, right? You guys are familiar with this method. Am I audible to everyone? Am I audible to all? Yeah. Okay. Then great. So here, okay, fine. So this is our method. Okay. So here, what I will do, I will say public static thing. I will say is strong. Uh, is strong, which will accept int n value. Okay. So while n is not equals to 0, n is not equals to 0, I will find out the unit digit. Unit digit is equals to n modulus. So this unit digit I will send it to. So before this, I will have int sum is equals to 0. Okay. Whenever I perform the summation value, so 1 plus 24 plus 120. So to store this sum value, this particular variable is there. You guys understood why I have created a sum value? So this basically this method is for finding out factorial of a individual digit. So this method's complete work is to receive your number, check whether it is strong or not, is strong or not. So to inform that this particular method is there. So here I have to store the value of some value inside a variable, right? So for that purpose, I have created this sum variable. So until my number doesn't get to 0, so I will be yo kanda first learn about strong number array. I will then again I will do first Armstrong afterwards. First understand what is being explained, Ra. First understand what I'm explaining here. Armstrong I will do in the next program. I know how to do that. Okay, first concentrate here. Okay, so are you guys understanding what I'm trying to explain here? Everyone. As in the starting, it takes a slightly extra amount of time to understand. I want everyone to reply over here. Please take a second of time to at least to reply yes, no, asking your doubts. Okay. So here, until my number gets empty, I will be performing the action. So I have obtained my unit digit. Yes or no? I have obtained my unit digit. So here I have my number. So this step is done. Obtaining the unit digit, that is done. So next what I have to do, I have to find the factorial value of the obtained digit, right? So for that, what I will do, so sum is equals to sum plus, so okay, I will say sum is equals to sum plus factorial of unit digit. So what am I doing? I am finding the summation value. Along with that, I am passing that value to the factorial value. So after this, I have to reduce it. So how to reduce a number? So I will say n divide equals to 10. Is my voice not audible to everyone? How many of you are not able to listen to my voice? How many of you are unable to listen to my voice? Am I audible now, Ma? Supriya? Please do check your internet connection because all the other participants are able to listen to my voice. Okay, please do check it once. So after performing this, okay, after performing this reduction of the number, so here I will say if So here, okay, where is this chat? Okay, so here what I will do, one more thing is, n is equal, sorry, not that, n is equals to, not n, temp is equals to n. So here what I will say, if temp is equals to sum, so before this, as it is a string value, what I can do, so string result is equals to not a wrong number. So here what I will do, result is equals to is a wrong number. I will say return the result value. So here what I have to do, int n is equals to 145. I will pass the n value. Number.java. From number. So shall we do a rough tracing here? Shall we do the rough tracing of the number, whatever I have explained here? So it's almost known process only. So it's quite lengthy. Let's do the tracing ones, okay? So always your execution starts from which method, ma? Always your execution starts from which method? Yes, yes. Everyone are correct. So in the main method, what do I have? I have a number which is 145. Inside this 145, this 145 is passed to which method? I am passing it to the is strong method. Yes or no? So when the method is called, the control goes from where to where? From the main method to is strong method. So here, what number is being substituted, ma? What number gets substituted in this method? That is in the point of n 145, 145, 145. Yeah, that is what I am explaining the tracing. Okay, that is what I am explaining the tracing. Please do observe here. Okay, so wait, if it is getting confused so much, let us come to OneNote. Okay, let me paste it. Let me increase it to 18. So I think so you guys can see this, right? So let us trace it here itself. Okay. Let's trace this here. So here in this line, yeah, shit. In this line, I am passing the value 145. Yes or no? Yes or no? I want everyone to actively participate in the tracing so that it will be easy for you to understand. Okay. So the same value 145 is being substituted here. So in this line, how many dabba we are creating? How many dabbas are we creating? How many dabbas are we creating? We are creating two dabbas. One is your sum value. One is a sum value which is initialized by 0. Next is a temp value which is having the value 145. So these two dabbas are created. So in the string value, I have assigned the answer as not a strong number. Okay. So after this, when we are coming down in this place, what is being substituted? What is being substituted in the first cycle? 145 not equals to 0. Yes or no? So 145 is not equals to 0. This is being substituted. So in this line, 145 modulus 10. So whenever I do this, what is the value getting substituted? 5 is getting obtained. 5 you are getting as the value. So here, what are we doing? I am having sum is equals to inside sum. What is the value? 0 plus factorial of unit digit. What is the unit digit we have obtained in the previous line? So I have obtained 5 over here. So I have obtained 5. So whenever you have obtained 5, so the control comes to your fact method. Yes or no? So the control comes to your fact method. So whenever you are substituting 5 over here for this method, so in the first iteration, I think so. I don't need to explain the tracing of factorial program. I think you guys know how a factorial program works, right? I think you guys know, right, how a factorial program works. I have explained it in the previous. I think I have done the factorial program, right? Yeah. So in the first iteration, so fact value is initialized by 1, and as I am finding out the factorial of 5 factorial, so what will be the answer inside factma? So fact will have 120. Yes or no? 5 factorial is 120. So what value is being returned here? What values is being returned? 120 is being returned to the placer. So if I do the addition, so 0 plus in the first cycle, in the first iteration, so sum will be 100 plus 120. So it is 120. So what happens now? What happens? Your sum value get initialized by 120. So next after this, n is equals to n divided by 10. So what is there in n? N is equals to 145. 145 divided by 10. So this becomes 14. So this becomes 14. So next, your let me write n value here. So n is having So in the first cycle, you had 145. So this was reduced to 14. So after this, is my loop finished? So I have to again go to the condition, right? I have to again go to the condition. So I will go to the next cycle. 14 not equals to 0. So here in the unit digit 14 modulus 10. So here what happens? You will get unit digit as 4. So here what happens? Sum is equals to sum. Inside sum I have 120 now plus factorial of 4. So whenever you are doing in the second iteration, whenever you are doing in the second iteration, so here fact will be assigned by 1, and when you find out 4 factorial, so the fact value will become 24. So this value will be sent back. So here what happens? 120 plus 24. So your value becomes 144. Everyone agrees with this? So here from 120, this value becomes 144. So here 14 divide equals to 10. So in this process, your value gets reduced to 1. So will my loop stop? Will my loop stop? No, your loop will not stop because still one digit is there. Still at least one digit is there. So 1 is not equals to 0. True or false? 1 is not equals to 0. Is it true or false? So as it is true, in the unit digit, your value will be 1. So next in this process, sum is equals to 144 plus 144 plus factorial of 1. So here what happens? 144 plus 1. So your value becomes 145. So here, as the number is already obtained, so this step will be done. After this, so your number is completely reduced. So is there any digits present inside n? So this one will be reduced. So this one will be not there. So once your loop is finished, you will come to this temp is equals to sum. So what is there in temp? So temp I have 145. So this 144 will be 145. So 144 equals to 145. So is it true or is it false? So here in sum I have 145. Here in temp I have 145. So as it is true, will it come inside the loop or will it skip the loop? Will it come inside the loop or will it skip the loop? So it comes inside the loop. So what happens? Your value gets reinitialized by is a strong number. So your value is reinitialized by is a strong number. After this, I am returning my answer. So whenever I return my answer, so that answer will be substituted where that answer will be executed in this line. So what will be the output we will be getting? 145 is a strong number. Understood? Understood? It is easy. Program is damn easy. Very, very easy. So here I will say I will attach this with the number itself, okay? So that it will be so now we will try to execute this PC online methods CMD. What is the command to compile? Ma? What is the command to compile? Java C. Java C. What is my class name? Strong number. Strong number. Strong number dot Java. ಉಲ್ಲೆಲ್ಲೆಲ್ಲೆಲ್ಲೆಲ್ಲೆ. ಎಲ್ಲೋ ತಪ್ಪಾಯ್ತು ಇಲ್ಲೇ Java strong number. So are we getting the correct result? Are we getting the expected result? So, so if you have understood this, so see here, that is why you have your definition whose sum of factorial of digits. See here, we are doing sum of factorial of digits. So if you have understood this, I'll go with the next example, okay? So I will go with power of a number, okay? I will go with which number? Power of a number. Uh, so what do you mean by power of a number? So for example, if I say 2 to the power of 3, what I will do? 2 into 2 into 2. Hey, wait. Sorry. So this program is for finding out. This program is for finding out if the single number is individual, if the individual number is strong or not. Sir, I want to find out for a range of numbers. What I want to do? I want to find it out for a range of numbers. For that, what we can do? Call your method inside a loop. Call your method inside a. So this applies for everything. Okay, this applies for everything. So it is the same program instead of your hello world. Instead of hello world, what I can do for int I is equals to 1, I less than or equals to 500, I plus. So here, if I don't want it. I will say is stronger. Fine. So just call away your method inside a loop. Understood? If you do this, you will get for every number whether it is a strong number or a not strong number. Okay. So it's just that simple. Understood the difference? If you want to print, if for example they ask you to print the strong numbers in between the range, so just pass them inside a loop. Okay. So here, so shall we continue with this power program? Shall we continue with this power program? Okay. So here, so here there are mathematical terms. Okay. So here, what is 2 called and what is 3 called? Whenever you do exponential calculation, what is 2 called? What is 3 called? 3 is called as exponent. Okay, then what is 2 called? What is 2 called? 2 is called as, yes, yes, super. So 2 is called as a base. So what is the work of base, ma? What is the work of base? It says which number to be multiplied. Yes or no? Exponent says how many times, how many times base to be multiplied. Yes or no? Yes or no? So, so, so having this thing in the mind, okay, having this in the mind, so I will say power of program. So I will say public static void power of. So here I will say int n is equals to, so not n, sorry, int base is equals to, I will say 2, exponent is equals to 3. Okay. Uh, double result is equals to 1. So for int I is equals to, I will start from where? I will start from, your loop will start from 1. So I will be less than or equals to how many times? The exponential times. Because the exponential says how many times your base number has to be executed, yes or no? Sorry, how many times your base has to be multiplied. So that is the deciding factor. So here exponent I plus plus. So understood the loop? Understood the loop, whatever I have written here. So I will start from 1. Your multiplication last point will be mentioned by exponent and I will do I plus plus. So here I will say result into equals to base. Result into equals to base. This is the what is that logic? A simple logic. So after this, so here I will say base exponential is equal to result power of. See, are we getting our correct answer? 2 to the power of 3 is equal to 8. So let's not get satisfied with the number. I will say 5 to the power of 3. Are you getting 5 to the power of 3 is equals to 125? Okay. Okay. Any doubt in this program? Any doubt in this program? It's just a basic multiplication program. Okay. If you have understood this, okay, I will give you an assignment. Okay. I will give you an assignment. Okay. So here is the so uh, so what are we talking about here? We are talking about Armstrong number. Which number? Armstrong number. So here I'll explain you what is Armstrong number. So basically you will be having a number, so which is 153. Okay. So first what you have to do, you have to obtain a number. For this number, what you have to do is you have to you have to count the digits first. What you have to do first, count the number of digits. Okay. So here, how many digits are there? 3. So what you have to do is, so this a kind of this process is there, right? For example, not this. I will say how to do this. Okay, how to do your count of digits. If n is not equals to 0, okay, if n is not equals to 0, what I will do, I will come inside the loop. I will increase the count value. Okay, I will increase the count value. After that, n divide equals to 10. No, 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 no. This logic you can use for counting the number of digits. Okay, this easy logic you can use for count of digits. Okay, so once you get to the count of digit, you have to you have to perform the similar action. Okay, until your number is not equals to 0, obtain the what is that uh, unit digit. And for your method, for example, if this is the method, if this is the power of method, and if I want to make it as a parameterized method, so I will say int base comma int power. So, so I will say base comma expo. So here, instead of expo, what will be there? Instead of exponential, this count will be there. You have to pass the count. So you have to pass this count value. So what happens here? So you will be having a power method, int base and int exponential. Okay. So this base will be the unit digit. This exponential will be your count value. Okay. So find out the power of individual number, and you will have something called as a sum value. Inside the sum, you will be adding these values: 1 to the power of 3, 5 to the power of 3, 3 to the power of 3. Understood? Understood? Similar to strong number. In strong number, you performed factorial, what is that? Factorial operation. In your Armstrong number, you will be doing your, what is that? Power will be 2. Power will be 2. See, I'll explain once again. I'll explain once again. So, what is my number, ma? 153. Yes or no? What is your number? Your number is 153. You should have a count variable. Inside this, the value will be 3, as the number of digits is 3. Okay. Next, you will have a power of method. Which method? Power of method. Okay. In Google, if you guys do, it will be only for 3-digit Armstrong number. But this kind of process, whatever I'm explaining, this is for any number of digits. This will be for any number of digits. Okay. So in this power of method, one is you will pass the obtained unit digit and you will pass the count value. Unit digit will be the base, count will be the exponential. Uh, Based on the count, based on your count, it will be your what is that exponential value. Next, what you have to do, you should have a some variable where you will be adding the values of individual number. Once you have done power of for all the digits, so what happens in the first cycle? In the first cycle, base will be 3, exponential will be 3. You will be getting one value, that is you will have 27. Next cycle, your unit digit value is 5. Exponential is fixed here. Exponential will not change. 5 into 3. Next, you will get 125. Next, you have base is 1, exponential is 3. You will get value as 1. So if you add these values, you will get 153. So if this sum value and your original value, if it is same, you will say it as Armstrong number. Easy. Everything is almost same compared to strong. The only difference is instead of factorial method, which method will be there? Power of method will be there. And one extra step is first counting the number of digits. And that count will be the fixed value for exponential. That count value is fixed for your power. Okay, try to do this program. Okay, try to do this program. Tomorrow I will explain the program. Okay, you have to try it. Okay, tomorrow I will explain the program. Okay, okay, buddies. I think you guys understood the program, whatever I have explained today. Okay, practice this. If you're unable to get anything, you have a classroom, Google Classroom. You can ask your doubts there. So whenever I'm free, I'll be answering your doubts. Okay. Thank you guys. Thank you for attending the session. Have a great evening. Take care. Tata. Bye bye. Stay safe. Let's meet tomorrow in the tomorrow session.